we're going to look at the periodic chart and variations in the different chemical properties of elements today. We're going to begin with the chemical properties of the elements, and we're going to begin with something that is the idea or the explanation behind the different trends. In some ways, explaining this will feel like it's overcomplicating them once you get into the trends and you realize that you can follow certain directions on the chart and make predictions about elements. We'll be looking at their sizes, we'll be looking at how much energy it takes to add and remove electrons, that kind of information. So it all has this underlying element of effective nuclear charge. And what effective nuclear charge is it's how well the valence electrons, remember those are the ones that do all the chemistry, those are the ones that get thrown on and off the atom. It's how well they feel the nucleus. So if an electron feels, if a single electron in that outer valence can feel all three of those protons at the same time, it's going to hold it in tight. But let's say that it can only feel one electron at a time. It'll still hold it in, but just not as tightly. So what we're going to be doing is we're going to be looking at how the core electrons or the inside electrons kind of hide some of the protons from the outer electrons, and how that allows how easy it is to take off that electron, basically, like the pull between those positive and those negatives, and how that pull changes. So to build the idea, we're going to start with lithium, which is on the left, and lithium does not have a very large effective nuclear charge. So lithium has 3 protons represented with red balls, 2 core electrons represented with green balls, and 1 valence electron represented with a blue ball or sphere. And this is how we traditionally draw lithium. Now, nuclear charge. What happens for the nuclear charge? Well, this little area here, these electrons are moving on the inside. They create kind of like a shield around the nucleus, and basically it's like a force field, and it only lets a little bit of the positive charge out at the time. So what happens is that this electron ties up one of the protons, and this electron ties up one of the protons, and you're left over with that outer electron only feeling the charge from one proton. You might be like, well, that kind of makes sense, right? Isn't it a proton to an electron? Not exactly. That's the weird thing. It's not like each proton has its own designated electron. We'll talk about that when we're talking about an atom being neutral, but at any point in time, an electron could feel the pull of more than one proton. Not in this case, because it's being shielded, but at any point in time, the electron could be influenced by multiple protons. So let's see some cases where that starts to happen. Over here we have beryllium. Again, we've got 4 protons. Notice we have an extra proton. We still only have 2 core electrons because we are just building in on this second energy level. So what's happening here is that, again, our core electrons are being mean, and they are hiding 2 of the protons from the outside electrons. So you can see in here, they're kind of making this shielding effect and hiding them. Just because we lose 2 protons, it doesn't mean we don't still have 2 that aren't being shielded. You're like, yeah, so the deal is at any point in time, this electron can actually feel the pull of both the protons at the same time. So it's a stronger tugging. And then also, they can feel the pull of both of those protons. It's like that nucleus has a stronger tugging effect on those electrons, and it may just pull them in just the tiniest smidgen of a bit compared to over here where it was just a 1-to-1 pull. All right, so let's look at how strange it can get. And we're going across the periodic chart, by the way. So now we have 2 more electrons from lithium. We have a total of 5. We still have our core electrons. So 1, 2 are canceled out. All of our valence electrons are on the same amount. So again, we're canceling them out. We're getting the shielding effect. And then now we have still needs to be red. 1, 2, 3 protons. At any point in time, all 3 protons could be pulling on this electron and tug him in quite tightly. Or they could be experiencing all of those ones or all of those ones. So you can see where the tugging in on these electrons here is stronger because there's 3 potential protons per electron at any point in time. Not that they always have the pull, but it's like an average effect. versus only 2 pullings per electron versus 1 pulling per electron. So what happens as you go across the chart is your atom actually gets smaller and smaller and smaller as you go across the chart. Can't get that very small because there are more protons who can pull in on those outer electrons. Is this a theory that we came up to explain why that happened? Yes, but it does seem to work, and you can do so many calculations with this. If you want to research it, Zeph right here is the term that explains how the electrons feel, outer or valence electrons, it's how they feel the nuclear pull from the protons. All right, do you have to understand all of that to understand what's going on with trends? No, it's just like an idea or a hook for the information to help you understand it. So we're going to go ahead and look at atomic radius next.